Hello everyone, this is Mr. McMillan and I'm here with an instructional video on angles and arc measures in circles. Okay, so we have talked about a few of these things as well as arc length and sector area and how we determine those in circles. And also when we looked at the different parts of circles, we talked about the various types of arcs that we had. Well, we're also going to be covering the different types of angles. But first, we're going to go back over the types of arcs to make sure we have a good understanding of those. So there are three types of arcs. The first type of arc is called the minor arc. And an arc that is a minor arc has a degree measure that is less than 180 degrees. And that's why it's called a minor arc. Okay. So do you see a minor arc in this diagram? So do you see an arc that would measure less than 180 degrees? And you should see that there are two of them in this diagram. The first is AB or BA. So arc AB. And the second one would be arc BC. Okay, so arc AB and arc BC. The next one that we talked about was a semicircle. And as you guys know, a semicircle is half a circle. And since a semicircle is half a circle, then that means the arc has a degree measure equal to 180 degrees. Okay. So in this diagram, do you see any semicircles here? And you should see one here at AC, arc AC. But you could also say that arc ABC is one. Okay, so arc AC or arc ABC. And notice here that having a semicircle is completely dependent on you having a diameter. So a semicircle requires a diameter. Okay. And then our last one, a major arc. This is an arc that has a degree measure greater than 180 degrees. So it has a degree measure greater than 180 degrees. Okay. So do you see an arc in this circle that you can name that has a measure greater than 180 degrees? Well, if we start at A, we could say that ACB is one. Arc ACB is one. If we start at B, if we go backwards, we just end up with the same one we just said. But if we go from B to A to C, that's another one in this diagram. Okay. And also we talked about the total angle measure of a circle. This is regardless of whether you have angles here or arcs here. That means that the total angle measure is 360 degrees. Okay. So in this case, the measure of AB plus the measure of AC plus the measure of BC is equal to 180 degrees because those are our three different parts. Or not 180 degrees, I'm sorry, 360 degrees. Apologies. Okay, so those are the types of arcs that we talked about. Now we're going to go over the types of angles. And there are four different types of angles. The main focus for today's lesson is going to be on these first two types of angles. And we'll talk about these other two types of angles tomorrow in more detail. So a central angle is an angle whose vertex is the center of the circle. Okay. And we talked about this when we talked about arc length and sector area. A central angle always has a vertex at the center of the circle, which is why it's called a central angle. Now, the important thing to know about a central angle and the relationship that it has with its arc, the measure of the central angle and its arc is the same. So they are congruent. Okay. So the measure of the central angle and its arc is the same, or it should say are the same. Okay. So that means that here, if we had ABC to be 115 degrees, then arc AC would also have to be 115 degrees. So the measure of angle ABC must be equal to the measure of arc AC. Okay, so central angles, a central angle is the same as the arc that it intercepts. And you can tell where it intercepts because you have A here and C here, and this is the intercepted arc. That's the portion that you're looking at. Your next type of angle that we're going to look at is an inscribed angle. And an inscribed angle is an angle whose vertex lies on the circle. On the circle. Okay, so you can see the angle B here has a point that lies on the circle, so this would be an inscribed angle. So the important thing about an inscribed angle measure is equal to half of its intercepted arcs measure. Okay, so an inscribed angle measure is equal to half of its intercepted arcs measure. So that means that if arc AC here, which is the intercepted arc, was equal to 110 degrees, that would mean that the measure of angle ABC would have to be half of 110, which is 55 degrees. So we would write that out symbolically. The measure of angle ABC is equal to 1/2 of the measure of AC. Or we could say that the arc has to be twice as long as, or twice as large as the measure of angle ABC in this case. Okay, so your angle for an inscribed angle is, your measure for an inscribed angle is half the measure of the intercepted arc. All right, next up we have interior angles. And where would the vertex lie for an interior angle? Well, an interior angle would lie inside the circle. It is formed by intersecting lines. Now, just like when we talked about vertical angles and linear pairs with two lines that are intersecting, this forms 4 different interior angles. It is important to note that a central angle and interior angle are not the same thing. An interior angle is off of the center. It's still inside the circle, but it's away from the center. Okay. Now, the important thing about an interior angle and its arc is that the measure, or the interior angle measure, is half of the sum of the 2 intercepted arcs. So it's half of the sum of the two intercepted arcs. Now you may be saying, well, that angle there only intercepts BC, right? And you would be correct. This angle BEC is associated with BC. But you have to remember that these are intersecting lines. So the key thing there is that it forms two pairs of vertical angles, and vertical angles are opposite of one another. So that means that this angle is congruent to this angle, which means we also have to use that arc as well. That's why we have to take half of the sum. We have to average those two angles or arcs out to get our angles in there, because those have to be exactly the same. So if we write that symbolically, we can say that the measure of angle BEC, now one of our arcs is BC, so the measure of BC plus the measure of AD all over 2. So that's half of the sum. Okay. And then our last type of angle we see in situations with circles is exterior angles. And an exterior angle, unlike an interior angle, is an angle whose vertex lies outside the circle. Okay, so the vertex has to be outside the circle, not on it, not in it, outside of it. It is also formed by intersecting lines. Now, the intersecting lines here could be tangents, they could be secants, it just depends. Either way, the method for finding the measure of an exterior angle is always the same. So if we added for an interior angle, what do you think we're going to do for an exterior angle? Well, with an exterior angle, to find its measure, so the exterior angle measure is half of the difference. This time we're going to subtract. So half of the difference of the two intercepted arcs. Okay. Now you can think of it like this. If you are with a group, if you are with a circle of friends, you are part of the circle of friends, you are an addition to that group, right? You're welcome in that group. You're an addition. So when you're inside of a group, when you're inside of the circle, you're going to add, you're going to take the sum. But if you're on the exterior of a situation, if you're outside of a group, then you are not part of it. They are different. They're not people you would hang out normally with. So they are different from you, so you take the difference when you are on the outside, when you have the exterior. Okay. Now, an angle measure here is not going to be negative. Okay, so it has to be positive. So that means that we have to take the bigger arc and subtract the smaller arc. So what is your bigger arc that is intercepted that's associated with angle C here? Well, your big arc would be AE, and your small arc would be BD. So writing this out symbolically, we could say the measure of angle BCD is equal to the big arc, which is AE, minus the small arc, which is BD, divided by 2. And if it helps you remember, big minus small over 2. Okay, so the big arc minus the small arc divided by 2. Now for our examples in this video, where you're going to focus on the central angle and the inscribed angle. In the next video's examples, we're going to be focusing on the interior angles and the exterior angles. And when I give you the worksheet, there will be some combination between these two types of angles. Okay. So let's look at some examples. So we're going to work through 8 examples here, and it says for problems 1 through 4, find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. So let's look at number 1. Number 1 wants us to find the measure of arc ED. So I'm going to go ahead and put an X on arc ED. Now, there are a few ways that you could do this. You know that you have angle or arc FE here, and it's 80 degrees. And since you know that, you know the central angle must also be 80 degrees. Now, if you look at this picture, you should notice here that FD, segment FD, is a diameter. And what do you know about the arc of a diameter? Well, an arc that's formed by a diameter would be a semicircle, which equals 180 degrees. So we know that this 80-degree arc and this arc we want to find are both part of a semicircle, right? So arc FE and arc ED are part of a semicircle. Well, a semicircle measures 180 degrees. Well, that means that to find our arc ED, we can take 180 degrees and subtract the other arc that we know that's part of that. And in this case, it would be FE. So we take 180 minus the measure of arc FE, which is 80, and we get that arc ED is going to be equal to 100 degrees. Okay. The other way you could have done that is knowing this was 80 degrees, so this would have to be 100 degrees because they form a supplementary linear pair, and then that would make your arc ED be 100 as well. All right, let's look at number 2. Number 2 wants us to find the measure of arc ZWY. So if we start at Z, we need to go to W. So we need to go here first to the left. So W. And then we're going to go and keep going until we get to Y. So this blue outline here on the edge of the circle is the measure that we want to find. We want to find the degree measure of that arc. Now, you'll also notice that you have a 60-degree angle and a 65-degree angle here. Well, you know that since you have a 65-degree angle there, you know that arc ZY has to also be 65 degrees because the central angle and its arc are equal to one another. Now, you'll notice here that this arc and the arc we want to find form the whole circle. And what is the sum of the arcs or angles in a circle? Well, that would be 360 degrees. So in order to determine arc ZWY, you take 360 and subtract arc ZY. So that means you get 360 minus 65 degrees, which is 295 degrees. Okay, so in a lot of these problems, you're going to have to make use of the fact that the sum of the angles and arcs in a circle is 360 degrees. All right, number three, we want to find the measure of arc IL, which is this arc here. So we have a 57 degree arc here at LK. And you should be able to tell that KI and LJ are both diameters. So if you know that KI is a diameter, then you know this part that I just outlined, KLI has to be equal to 180 degrees because it would be a semicircle. Well, if we know that that equals 180 degrees and there are only two parts, we know that x plus 57 has to equal 180 degrees. So we subtract 57 from 180 to get our x. So we get x is 123. So that means arc IL has to be 123 degrees. Okay. And number 4, the measure of arc UR. We want to find that one. And we know the measure of arc ST is 135. Now with that, there's a few things that we could do, but I'm going to go the central angle route. So I know that the central angle that is associated with this arc would be the same. So this angle here would have to be 135 degrees. Now, do you notice that we have two intersecting lines here? This is where that vertical angle and supplementary angles comes into play. So we're looking here, we know this angle is vertical with this angle, so we know that these two angles have to be the same. So we know that this angle is 135 degrees, and since this is a central angle that's associated with arc RU, we know arc RU has to be equal to 135. And some of you guys might be saying, well, couldn't we have just said it was 135 because we know ST is the same as RU? And yes, in this case, we do know that that's true. But I wanted to show you why that was the case. And it's based on vertical angles. All right. So let's look at numbers 5 through 8 here. It wants us to find the measure of the arc or angle indicated. So on number 5, you see that it wants us to determine this angle here. Now you'll notice this angle here is a bit different than the ones we did before. This time, K is on the circle. And anytime you have an angle that's on the circle, with a vertex on the circle, it's called an inscribed angle. Okay, so an inscribed angle is what we have here. Now, from our previous thing, we talked about inscribed angles, and we said that the angle of that was inscribed is 1/2 the measure of the arc. Okay, so we're looking for the angle here. So we're looking for the measure of angle MKL, and we know it has to be 1/2 of the intercepted arc. Now, what arc does it intercept? Well, here to here is the arc that it intercepts. So our arc that it intercepts is 88. So the measure of K has to be equal to 1/2 of 88, which means that the measure of angle K is 44 degrees. All right. Number 6, we see that angle E is given to us as 46, and this is also an inscribed angle. Now this time we're looking for the arc that's associated with that angle. Well, we know that the angle is equal to 1/2 the arc because this is still an inscribed angle. But we already know the angle in this case, and we want to find the arc. Well, we know that the arc has to equal 2 times the angle. So in this case, we know that the measure of arc DC would have to be equal to 2 times our angle 46 degrees. So that means we get 92 degrees for our arc DC. All right. Number 7, we want to find the measure of angle W, and it is an inscribed angle because it lies on the circle. And we need to figure out which of our arcs is the intercepted arc. So we start where the angle goes. So we start at P here, and then it goes to R. And so we do everything in between there. So P to Q to R. Now you'll notice that we have two different parts labeled here. We've got one for PQ and one for QR. But we need the whole thing. So that means that the measure of arc PQR is equal to 68 plus 74. And that is equal to 142. So PQR is 142. Well, angle W is an inscribed angle. We know what the intercepted arc is. So we know that the angle is 1/2 of the arc. So the measure of angle W must equal 1/2 of 142. So the measure of angle W is 71 degrees. And finally, number 8. Number 8, we want to find angle S, and this time all we're given is that angle D is 120. So if we're looking at this using our inscribed angles, because both of these are inscribed angles, for angle S, we want to use this arc because it's to R and T. So we want to use arc RDT. But there's no way we can figure out what arc RDT is right now. However, we can do something to help us find it. We also have arc or angle 120, which is associated with arc RST. Okay, it's also associated with arc RST. Now, since angle D is an inscribed angle, that means that the angle is half the distance of the arc, or half the measure of the arc. So that means that the measure of angle R, or sorry, not angle RST, but arc RST has to be equal to 2 times the measure of angle D. So that means the measure of RST has to be equal to 2 times 120, which is 240. Now, you may be asking, well, how does that help us find the angle or the arc that we need? Well, you'll see here that this orange plus this blue area makes the entire circle. And you know that those two angles or those two arcs would have to add up together to give you 360. So the measure of RDT has to be equal to 360 minus 240, which in this case is 120 degrees. Now we know that angle S is an intercepted or is an inscribed angle with an intercepted arc measure of 120. So the measure of angle S is 1/2 of 120, which is 60 degrees. Okay. And that's going to do it for this video, guys. The assignment is posted on Google Classroom. I will write it down here on the bottom. It was IXL's U.2 to a 70, U5, or sorry, U11 to a 50, and U12 to a 40. Okay, so work on those. You can always refer back to this video. In the next video, we will be covering the interior and exterior angles, as well as a couple of other problems on central and inscribed angles. Okay. If you have any questions, please let me know. Thanks, guys, and I will see you in the next video.